Welcome today to the HCC Kickstart. We do this event every fall for new or existing users of the Holland Computing Center to give you guys a little bit of a jump start or a kickstart into how to use our systems and just a basic overview of the services that we provide. Actually, there's a couple other people possibly that will be helping during this workshop that are not included on this slide, so I apologize. One of those is Hui Jean, because I wasn't sure if she was going to be here today, so sorry, Hui Jean, I'll add you to this slide later. Thank you for all the helpers, and thank you for all the participants for joining this morning. So who are we? We are the Holland Computing Center. We have two locations. One is in the Shore Center, which is just at on the south side of the stadium at UNL. And the other one is at the Peter Kiewit Institute at UNO. We provide research computing resources to researchers from the entire University of Nebraska system. So that includes UNL, UNO, UNK, and UNMC. We have two primary supercomputing clusters called Crane and Rhino, and we'll be talking more about the details of all of these services and machines that we have. Mostly on Wednesday, we'll talk a little bit more about the details of what Crane and Rhino are and how to use the resources themselves. Crane is our newest resource. And Rhino is a little bit older, but there's a lot of good large memory nodes on Rhino, so it's still very usable. We also provide a cloud computing service called Anvil, and we have long-term data storage available at subsidized pricing, and that's called Attic. So if you have things that you need to store long-term, please look into that service, because we do not recommend that you store valuable things on our clusters in their home directory. We also provide research facilitation services, so troubleshooting your jobs, one-on-one consultations, outreach events like this training that we're doing right now, customized solutions for your code, so sort of helping you get your code, make small changes to it so that you can run it on our clusters. And we also install software on our clusters for people at request. So most of these services are free, or at least basic access to these services are free. If you'd like priority access, like to lease an entire node, for example, or to use Attic or something like that, then we do have subsidized pricing for your group. I included a few links down at the bottom of the page here. So our webpage, where you can learn more about all of these things, is there. The docs page is also linked from the web page, and it's searchable. So if you can't find something just from browsing, you can definitely search for it and you should be able to find it. If not, if you can't find it there, then please email us. Okay, so we're going to be going over these topics in the next 5 days. This is just basically copy and pasted from our workshop website, so nothing new here. But today and tomorrow we're going to be doing the Linux shell. This is just covers the basics of how to interact with the operating system on our clusters using a shell interface rather than a graphical user interface. And this will cover most of what you would need to know to use Crane and Rhino from using the command line. So nothing really fancy here, but just covers the basics, and plus a little bit more that maybe you don't even need to know, but that can be really helpful. On Wednesday, we'll go into the details of HCC and what services are available, and all of the different aspects of our clusters. And we will also teach you how to submit jobs to our scheduler, which is called Slurm. On Thursday, we'll talk about applications or software, how to use your software on Crane, and how to manage your data and transfer it to and from the clusters. And then finally, on Friday, a few special topics. So we'll talk about the cloud Anvil, You'll be given an introduction to our Open On Demand service, which is kind of a web-based portal for people who are not comfortable with command line. There's a couple other features to that, like Jupyter notebooks and interactive desktops, which can be really handy. And then finally, you'll get a brief introduction to the Open Science Grid, which is a national consortium of that combines or amalgamates computing resources from institutions all over the country. So if you'd like to have access to running your jobs on the Open Science Grid, and if your jobs are a good fit for the Open Science Grid, we'll talk about that on Friday. Okay, so are there any questions about the overview? If not, I'll go ahead and kind of jump right into our Unix shell lessons, which is what we're going to be doing for the next couple hours. I only have a few slides, and then we're going to actually just do hands-on exercises for the rest of the time. But first, I want to talk about what is the Unix shell. Not everyone has used it before, so you might not even know what it is and why you need to learn it. It's basically just a way of interacting with the operating system of a computer. And in this case, it's going to be our cluster, the login node of our cluster. So instead of using a graphical user interface, which you might be more familiar with from your laptop or your desktop computer, it's a command line interface. So you enter your commands directly onto the command line. Each command is itself a little program, and it runs the program and executes the command and prints output to the screen on the terminal. We're going to be using the bash shell, which is the most common variant of the shell. In case you hear the name, hear the word bash, you'll know that that's just one of the Unix variants. The shell commands that we're going to be learning, they can be a little bit cryptic at first, but most of them are kind of based on English words, so they're not too hard to remember. And there's only about 10 or 15 basic commands that you'll need to know, or at least know that those commands exist in case you need to just Google how to do something again. That's fine. But if you've learned it once, you should be able to learn it again more easily the next time. So it's good to just have seen it. And then you'll know that that's something that you can look up if you need to, or maybe you can refer back to our lessons pages in case you just need to refresh your memory or want to redo any of the exercises. Those pages will be available. So why would you want to learn the Unix shell? Well, as hopefully you will see over the next couple of days, it's a very powerful tool set that allows you to automate repetitive tasks quickly. And it's also an easy and sort of quick shorthand way of interacting with remote machines. Unix-based operating systems are used on almost all high-performance computing clusters. And so even if you are going to use a different cluster from a different institution, it's a good skill to have. We're going to be logging into Crane and using the shell that's on the login node so that we all have the same experience and there's consistency, because when you can run these commands in the terminal or the command prompt of your local machine, but we might see slightly different things because you might have a different version of it there. So we're all going to be running it on the cluster, which is good because on Wednesday and Thursday and Friday, we're going to be doing submitting jobs to the cluster. So we want to have a little bit of experience logging in and using the cluster before we get started with those. Okay, so this slide shows just a bulleted list of all the different modules that we're going to be covering during the Unix shell lessons. Underneath each main topic are a few of the commands that you'll be learning during that lesson. So those probably don't make sense to you if you haven't used the shell before, so don't worry about that. We'll be learning those later. Today we're going to be covering the first 4 lessons essentially. Well, the very first one is extremely short, but basically the first 3 lessons there: navigating files and directories, just basically moving around in the shell to your different directories and seeing what's there. Working with files and directories, so creating files, creating new directories, moving things around, renaming things, copying things, and deleting things. And then finally, we'll talk about pipes and filters. And this I will explain when we get there. So this is kind of a little cheat sheet, although you'll probably find even better cheat sheets online if you just Google. But this is a basic summary of the commands that we'll be learning today, today and tomorrow. And it's not a complete list, but you can see that it's really not that much to have to remember. And you can definitely refer to this later if you'd like. Okay, so let's go ahead and get started. The first thing I want everybody to do, and hopefully you've already done it, is to log into Crane. So make sure that you are logged in, and then have a browser window open and have a couple links open, because we will be using these links and referring back to them. So please open up these two links. You can put them in the chat in case you would like to copy and paste them. Okay, so the first one is a link to the command history. So every time I enter a command on the command line, it will show up in the command history in case you missed something and want to go back and look at it because you got behind or something like that. You should be able to view it on that at that first link. I think what's there right now is just one command, clear, because that's the first command I entered this morning. And it refreshes about every 10 seconds. So if you don't see something I just entered, just wait a few seconds. The second link is a link to the lessons that we're using from software carpentry. So I will be having you guys open that to complete the exercises from time to time. So you want to have that open. Okay, I'm going to stop my screen share and then share my my whole desktop for the next part, so that you guys can see my terminal. It'll just take me 1 second. I will try not switch around how I'm sharing my screen too often, because I know it can be annoying when it changes. So, okay, hopefully everybody's logged in. But this is how you would do it. Let me know if the font is too small or anything. I'm using a demo account, so my username is demo01. Okay, so I enter my password and then it asks me how I want to authenticate, and I enter 1 because I'm using Duo Push. It sends a notification to my phone. I have to open that. Open the app if it's not already open, and then just push the green approve button. And now you can see I'm logged in. Does that work for everybody? Put up your the red no button by your name if you have any issues with that. Okay. All right, we're going to go ahead and get started and jump right into the lessons. As you can see on the left, I have the command history window open. I'm going to open another tab. This is the lessons link. So the first lesson we're doing is introducing the shell, which we kind of already did. The first one that actually has exercises with it is navigating files and directories. So if you want to have that open, then that will be helpful in a few minutes when we do our first exercise. So the command history is here. How does the font size look in this terminal? So if I enter clear again, it should show up in the software, in the history over here on the left. Okay, let me know if that font size is too small or anything. Okay, so I am logged into Crane right now. This is the login node, and I am using a shell on the login node. And that's just, like I said, it's a program that we use to interact with the computer's operating system. And we use it to run other programs. And the first thing that you'll see is the command prompt here. This is a $, and that means that it's waiting for input. So let's go ahead and enter our first command. It's called who am I, and then enter. And this will just print out your username. Right, so what happens is the shell command is, like many of the shell commands, is typically just a shortened or abbreviated word. So who am I is actually a program. And when the shell sees that program, it reads it, looks for the program called who am I, it runs the program, and then displays the output from the program to the terminal. And then it shows the command prompt when it's finished to let you know that it's waiting for the next command. And this is called the read, evaluate, print loop. So let's go ahead and enter our next command. This one's very useful. We'll use it a lot. It's pwd, and that stands for print working directory. That's going to show what directory I'm in. So you can see that I'm in my home directory. The output is a list of nested directories. And you'll see that the last directory is the one that we're in. And it's sort of like a tree. So if you, let's open up the lesson link, and you can see there's some images that show what a directory tree looks like typically. So typically it starts with the /, and the meaning of that first / is the root of the directory tree. So this is the root, and then beneath that are a set of directories and files, and beneath those subdirectories are lists of more files and directories and so on. So you can see why it's described as a tree. The / character actually has two meanings. The first one, like I said, that's the root directory. And the subsequent ones in this nested directory listing are just to separate the names of the directories. Okay. Okay, so let's try another command. ls. ls means listing, and it lists everything that's in my current directory. You might not have anything in yours yet, because if this is a new account for you, you haven't put anything in there. I have something called command history. That's a directory. But you might have no output because you don't have anything there. Or maybe you use Crane a lot and you have a large number of files already in your home directory. Okay, so for these exercises, we're going to be using a set of files and directories that's already been created specifically for this lesson, and we need to download that. So we're going to enter this wget command at the command line, which will download it. So we need wget and then space, and then the website where we're going to download it from. And then I will put this, this will end up in the command history. So once I enter it, you will see it here, and you can copy and paste it to avoid having any typos. Okay. Now if I type ls again, I see that there's this zip file that I just downloaded called shell-lessondata.zip. And here it is if you'd like to copy and paste it from the command history. Okay, now we need to unzip it.
Where to copy and paste? Sorry.
Yeah, so this is the command history window that I asked you guys to open earlier. It's just a link. Okay, so the next command we're going to do is unzip, to unzip this file. And I'm going to do -Q to make it quiet, so it won't list all of the files to the terminal when it unzips it. Okay, now if I do ls again, I see there's the zip file is still there, and now there's a new directory called shell lesson data. And I can go into that directory and see what's there. So how do I get into that directory? The command for that is cd, which stands for change directory. So it's CD and then the name of the directory you want to go into. CD shell lesson data. Okay, so right here, I'm not pressing enter quite yet. This is the relative path of that directory I want to go into. I want to talk briefly about relative paths versus absolute paths. So relative path means it's relative to the current working directory. So it's relative to where I am right now. So if I just enter the name of the directory, it looks where I am now for that directory. And if it can't find it, it'll give me an error. I could also give it the absolute path of where I want to go. And if I do that, I need to start with the root directory. So I could either do CD shell lesson data, or I could do the absolute path, which is CD home demo 01 shell lesson data, right? That's the full absolute path starting at the root directory. Okay, so that's two different ways to describe where I want to go. Okay, I'm going to just do this one. I'm going to just use the relative path. Obviously, that's quicker in this case. And then I can do pwd again to print my working directory, and now I'm in shell lesson data. Now, just to, you probably already realized this, but my home directory is different than your home directory. Everybody's should start with home, and then it will be your group name, and then followed by your username, right? Everyone's home directory is going to be different. Okay, great. So let's see what's in the directory shell lesson data by typing ls again. You can see there's a number of things. Some of them are directories and some are files. There's a color coding here, which makes it easy to determine which are directories and files, but you could also do ls-f. That would help you by putting a slash in front at the end of the directory names and no slash after the file names. So it makes it even more easy to tell which is a directory and which is a file. Okay, so one of the files is, or one of the directories is called data. What if I want to see what's in that directory without actually CDing into the directory? So I don't actually want to move into the directory, I just want to see what's there. I can type ls-f and then give it the directory name. And once again, this is the relative path to that directory. Okay, so now I'm looking inside the data directory and I see a number of different subdirectories and files in the data directory. So shell commands have a lot of different options. One of those that I just showed you is -f, but there's a lot of different options for the ls command, and you can see what those are by, there's a couple different ways. You can do ls-help, and that will print this long help message to the screen that gives all the different options and how to use them. You could also view the manual for the ls command by typing man space ls. And that opens up the manual page that you can page through the up and down arrows. And then press, to get out of this window, press Q to quit. Okay, so there's man pages for almost all of the commands we'll be learning today. All right, so let's go ahead and do the first exercise. So go to your browser window and click on the lesson link that I showed you earlier. We're on Navigating Files and Directories, and scroll down to the exercise. All of the exercises start with a little pencil icon. Okay, so they're kind of an orange color, and they have a pencil icon on the top left here. So go ahead and do these two exercises called Exploring More LS Flags and Listing in Reverse Chronological Order. The solutions are available here if you click on this button. So I will not necessarily go over the solutions afterwards unless people have specific questions. So I'm going to give you guys just a few minutes to work on these, and then we'll move on to the rest of this lesson. Put the red no button by your name in the participants panel if you have questions, and use the green yes button by your name when you've finished these 2 exercises, so I know when it's time to move on. And go ahead and, just unmute yourself if you have a question, that's fine. All right, is anyone still working on that and needs a little time? The basic point of these exercises were to show a couple of the different options that you can use with LS. So the human readable option, which shows file sizes in human readable units. The -L option, which shows different attributes of the files and directories that it lists. -R lists things in reverse order. So by default, they're listed in alphabetical order, but you can have it reversed. And then -T lists files by the time that they were last changed instead of alphabetically. And then you can combine these flags in a lot of different ways to have the ls command do exactly what you want it to do. Okay, so let's go ahead and move on. I'm going to clear my screen so everything's back up at the top. So I just typed clear and then enter. Okay, so let's find out where we are now. We're still in the shell lesson data directory. What if I wanted to cd into the data directory and ls from there? I can just type ls to see what's in the data directory. Or ls-f. So what if I want to go back up one level, though, to shell lesson data directory? There's 2 different ways to do that. Well, there's probably multiple different ways, but 2 main ways. I can either do cd and then give it the absolute path of where I want to go. So I would do home, demo 01, shell lesson data. That's kind of a lot of typing, not particularly convenient, right? So there's the shortcut for that. I'll do this first. So that's the long way. Let's go back to data again. So cd data. And now I want to go back up one level using the shortcut method. So that's cd and then ... stands for the directory containing this one. So it'll take you up one level in your directory tree. Okay, so pwd, we're back up in the shell lesson data directory. I'm going to introduce another flag or option that you can use with the ls command. So let's try ls-f-a, small a. So that shows directories and files in the current one. And it also includes these here, which are hidden directories and files. So anything that starts with a dot or a period is going to be hidden, and it won't show up if you don't use the -a flag when you type ls. So you'll see there's a directory or a file called bash profile that's hidden. That's to make it harder for you to delete it probably. And then there's 2 of these directories. One is ... and that's just like I said, it's the parent directory or the one containing this one. And then the other one is just ... and that's short for the current directory. So that's just a stand-in for the current working directory. So what would happen if I did cd data /... So that's asking the shell to take me to the data directory, and from there to go up one more directory tree. So I would go down 1 and then up 1. So where would I end up? So I ended up right where I started. Does that make sense? So I go to the data directory, and then I say from there, go to the parent of the data directory, which is the one I'm in currently. What if I do cd dot? Any idea what that will do? So dot stands for the current working directory. So what I'm asking it to do is take me to my current working directory. So that also doesn't change anything. It keeps me in the directory I'm in already. Okay, what if I type cd without any argument at all? Any idea what that will do? This it's just something we haven't talked about yet, so you shouldn't already know necessarily. If I do cd with no argument and then I type pwd to cym, I'm in my home directory. So cd with no argument will just bring you to your home directory. Okay, let's go back to the data directory. cd, I want to go back to the shell, lesson, data, and then from there go to the data directory, which is a subdirectory of that one. So I can do it in, I don't have to do it in 2 different commands. I can do it all in one command by stringing these together with the /. Okay, a couple more shortcuts I wanted to introduce is the tilde operator, or I guess it's a shortcut for your home directory. So we could do cd space tilde. That will do the same thing as cd without any argument. Tilde is your home directory. So I could say cd tilde and it takes me back to my home directory. I can do cd tilde / shell lesson data / data. And that you can see it replaced the tilde with my home directory. And then finally cd dash, a little hyphen, that will take us to the previous directory that I was in. So what was I in right before I did this? I was in my home directory. So cd dash will take me back to my home directory. Okay, does that make sense? Just a few shortcuts. I mean, you'll use probably tilde quite a bit, and the dot and the dot are going to be especially useful, I think. All right. So we're going to be using some files that are in the North Pacific Gyre directory. So let's go to that. Let's go back to home and then shell lesson data. Let's go back there and do ls again to see what's there. So I see this directory called North Pacific Gyre. I think that's how it's pronounced. I want to list what's in there. So I'm going to type ls North Pacific Gyre. Now that was kind of a long directory name. So one really, really useful thing to remember is tab completion. So if I just type the first couple letters of the file or directory and then type tab, it will complete it for me. However, you have to type enough letters that it's unique. So if I just type NO, it won't know if I'm talking about North Pacific Gyre or notes. So if I type tab here, it's not going to complete it for me. But if I type NOR tab, it will auto-complete the name of that directory that I wanted. That's really handy for long directory and file names. All right, there's a subdirectory in there called that's dated, so it's called 2012-0703. Let's look in there as well. So I can type NOR ls NOR tab, and then just like I could do anything, I could just type the 2 and then tab, and it would auto-complete it for me. So that's really handy. And then there's a bunch of files in here that we're going to be using tomorrow, actually. All right, one more tip. So hopefully you remember all these, but we'll be using them a lot, so I think you will. One more helpful tip are using the up and down arrows to locate previous commands. So if I want to enter a command that I entered like 5 commands ago, I would press the up arrow 5 times, for example. So up arrow 1 time brings me back to the last command I entered. Up arrow again will bring me back to the one I entered before that, and so on. So if I just keep going up. It'll just take me through all the commands that I entered recently. That's very useful if you want to re-enter something that you know you just did a few commands ago. All right, let's go ahead and do some more exercises. We're going to do all the rest of the exercises that we have time for in the current lesson. So we're going to go back to this browser that has the exercises in it. We're still in the navigating files and directories lesson, and scroll down past the exercises we just did and go to the next set of exercises. So it starts with absolute versus relative paths. So go ahead and do as many of the exercises as you have time for. We'll spend maybe the next 7 to 10 minutes on this, and then we'll all come back and see if we have questions. All right, so we're going to continue on with the next lesson, which is about working with files and directories. So if you're following along in the software carpentry lesson links in your browser, we were at navigating files and directories. So if that's the page you're on, go click back so that you are on this main page with all of the lessons listed, and then click on working with files and directories. So we will come back to this page when we do the exercises, but for now we're going to use our terminal. So what we're going to learn about next is how to create, remove, copy, move, and rename files and directories. So we all want to be in the same directory, the shell lesson data directory. So type pwd, and that's where you should be. I'm going to clear my screen, so I just type clear. You can do that if you would like as well. I'll type pwd again. So we all should be right here, except your home directory, of course, is different than mine. Okay, let's do ls-f again. We see the same files and directories we did before. I want to make a new directory. So how do I do that? The command for that is mkdir, which stands for make directory, of course. And then followed by the name of the directory you want to make. So I want to make something called thesis, make dir thesis. Now if I do, let's see. So just a couple of things to note. First, is that thesis is a relative directory, so we don't need a slash in front of it. I want to create it in my current directory. And it's also a good idea not to put spaces into directory and file names. And instead, if you wanted a space in there, you could do make dir my underscore or dash thesis or something like that, right? So just replace any spaces you would have with underscores and dashes. Don't start a directory or file name with a period, because unless you want it to be a hidden one, which we don't. And don't start it with a dash. So don't do make dir dash thesis, because then it can be interpreted as an option on the command line. Okay, so just some things to keep in mind about choosing file and directory names. So let's do ls-f again, and we now see that we have the thesis directory here that we just created, but it's empty. So I can cd thesis to go into that directory and do ls, and there's nothing there yet. I want to create a new empty file, and I can use the touch command for that. So it's just touch space and then the name of the file you want to create. I want to call it draft.txt and then enter. Now if I do ls, I see draft.txt is there, but obviously it's empty because I haven't put anything in it yet. Let's put something in there. So we're going to use a command line editor called Nano. It's just one that we like to use during software carpentry lessons because it's fairly user-friendly, but you might have a favorite editor that you'd rather use. Today we're going to use Nano though. So the command to open up and start editing that file is nano, and then the name of the file, draft.txt, and then enter. And then you'll be in this editing window. And then when you're done, you need to exit out of the editing window to go back to the command line. So let's just type something in here first, though. I'm going to just type some text. It's not publish or perish anymore. This is just from the software carpentry lessons. This is what they put in there. It's share and thrive. Okay. And then I'm going to save it. So all of the commands for your nano editor are hopefully down here at the bottom for you. The little up arrow is a command, or I'm sorry, control. So to save it is write. So you're writing the file. So you do a control O. Do the control O, and then it asks you down here at the bottom, it says, is this the name of the file that you want? And you just press enter, and then it saves it. And then to exit, that command is down here at the bottom. It's just a control X. So hold down control and type X, and then you'll be back to your command shell. Okay, so for anyone who was not able to do that, the command is just nano, and then the file name. So it's nanodraft.txt. So let's do it one more time. Make sure there's no typos in there. Great. So if you do that and you want to type something in, you can just type some gobbledygook if you want, and then type control O to save, and then control X to exit. Okay. And if you type control X without saving first, it will ask you if you want to save it. So that's kind of nice. Okay, so that was how to create a new file and how to create a new directory. How do we move things, and how do we rename things? So let's go back to let's go up one level to shell lesson data. So we should all be in the shell lesson data. Oops, the shell lesson data directory now. We did cd ... to go back one level up. Okay, I want to rename a file. So I don't like draft.txt. I want to call it something else. So I use the mv command, which is short for move. So you can use the move command to move something to a new location or to rename it. So I'm going to rename the file that's in the thesis directory, and it's currently called draft.txt. So that's my first argument, is the file that I want to rename. The second argument is the new name I want to give it. I'm going to call it quotes.txt, and I still want it to be in the thesis directory. So I make sure to specify that, because I'm not in the thesis directory right now. Okay, that's why I need this here. Now, if I do ls thesis, I see it's called quotes.txt now instead. So it's easy to accidentally overwrite a file if that file name already exists. So one thing you could do is use mv-i instead of mv. So you do the same exact command you did before. I'm using the up arrow to go back to that command, right? And instead you do -i here. And then if you do that, it will ask you first if you want to actually, do you really want to do that? And you would say yes or no, okay? So I'm not actually going to enter the command again, but I just wanted to show you that. Okay, move also works if you want to rename a directory. So let's say I don't want it to be called thesis anymore. I want to rename it new thesis. So mv thesis is the old name, and I want to give it a new name called new _ thesis. Remember, because we don't want spaces. Now, if I do ls, I see new thesis is there now instead of thesis. I would like to change it back. I don't like that, so I'm going to do that. Move new thesis, and I'm going to call it thesis again. Okay, ls, and now it's called thesis. And remember, it's over here now because it's in alphabetical order. So, okay. So let's use the move command to move something to a different place. Instead of renaming a file, I'm going to move the file. So I'm going to move the file that's in the thesis directory, and it's called quotes.txt. And where do I want to move it to? I want to move it into my current working directory. So I want to move it into the shell lesson data directory. And a shortcut for that, if you remember, is just the dot. Just that means my current working directory. So if I give it a file name followed by a directory location, it will move it to that location. Now if I type ls, I see that the thesis directory is still there, but now my quotes.txt file is in the current directory instead of thesis. So if I type ls thesis, it should be empty. There should be nothing there anymore because I moved it. Okay, we're going to do 2 exercises. Actually, we're going to do, I'm sorry, 1 exercise. So go to the Working with Files and Directories webpage here, software carpentry lesson, and scroll down to, hold on, did I skip it? Moving files. Nope, I'm sorry. That's not the one I want. Moving files to a new folder. Yes. Okay, let's go ahead and do that exercise. I'll give you just a couple minutes and then we'll move on. Speak up or put your red no icon by your name in the participants panel if you have any problems. Right, this is hopefully a short one. I'm just going to go over it with you guys, but it could, because it demonstrates how you can move multiple items with one command. So we want to move. It says Jamie realizes she put 2 files in the wrong folder, and they should be in the raw folder. So we need to move them. So currently, if she looks in the analyze folder, sucrose and maltose are in that folder, but she wants them in the analyze folder. So what's the command for that? She can move both of them in a single command. So that's the 2, she types mv with the 2 names of the files that she wants to move. And she's in the analyze directory. You can see she moved to the analyze directory. So if she wants to move them to the raw directory, she needs to do a ... So it will take it up 1 level and then back down into the raw directory. If she didn't do the ... it would not be able to find the raw directory because the raw directory is not inside the analyze directory where she's currently located. Does that make sense to everybody? So if you do the move command followed by a list of the file names you want to move, and then the final argument for the move command is a location or a directory name, it will move those files to that directory. Okay, let's go ahead and move on. We're going to talk next about copying files and directories. So we've moved and renamed files and directories. What if we want to create an identical copy of a file? And for that, we use the cp command. So I'm going to make, let's do ls again here. We see we still have the quotes.txt file that we created and then moved into this directory. So let's make a copy of it. Copy quotes.txt. So the first argument, the argument is what you type after the name of the program you're running. So I'm running the program cp, and the first argument is quotes.txt. The second argument is what's the name of the copy I want to create. So let's call it quotations.txt, and we want that to be located in the thesis directory. Okay, so we can give it a new name and we can also give it a new location. Now, if I type ls with the name of a file, it will just show me if that file exists. It will give me an error if it doesn't exist. So I want it to show me if this file exists, the original one, and I want it to show me if this file exists, the copy I made. And it did not give me an error, and it showed it's showing both of those files exist. So, so it worked. Next, let's say I want to copy a directory and its contents recursively. So I want to take a directory and all of its contents and make a duplicate of that and make sure that everything in that directory is copied as well. For that, I do copy -r. So the R stands for recursive. So don't just copy the directory itself, but all of its contents. Let's create a copy of the thesis directory. And then the next argument would be whatever we want to call that copy. I want to call it thesis_backup. So if I do ls thesis, that will show me what's in the thesis directory. And I can also have it show me what's in the thesis backup directory. So in the thesis directory, I have a file called quotations.txt. And in thesis backup, I also have the same file. Okay, so that's how to copy recursively. Okay, we're going to do one more exercise here. We're going to go to, we're going to do renaming files and moving and copying. So I'll give you guys a couple minutes. These are kind of short, so let's work on these until 11:25. Okay. So those exercises kind of build on what we already did. They don't actually introduce any new information. It's just practicing what we already learned. So if you weren't able to complete them in the time that we had, don't worry about it. You can always go back to it later. Okay, we're going to go ahead and move on and learn how to remove files and directories. So we talked about renaming, moving, copying. But what if you want to delete something? Okay, I'm going to clear my screen. Okay, so let's make sure that we're all in the same place. We should all be in your home directory and then shell lesson data. If you're not there, you can type cd /shell lesson data. Use that tab completion to make it faster. Okay. Okay, let's type a ls here to see what we have. Same as before, we have this quotes.txt thesis and thesis backup. Let's say that we want to delete the quotes.txt file. So the command for deleting or removing something is rm, short for remove. Now let's be very careful though. When we remove something in the shell, it's permanent and there's no recycle bin that we can go and rummage through later to pull it out of. So be really careful. If you'd like, you can always include the -i option, which will have it ask you for each item and have you confirm that you actually want to delete it in case you make a mistake when you enter this command. So let's try that with quotes.txt. Now it's going to ask me, yes, or it's going to ask me, do you want to remove it? And I have to answer yes, why, enter. Okay. Now, if I try to list it, it gives me an error because it's deleted. Okay. What happens if we try to delete an entire directory? I want to delete the thesis directory. And it says it can't because it's a directory. So rm typically only works on files unless you ask it to remove something recursively. So we can do that. We can remove the thesis recursively, which will remove the directory and all of its contents. Now this is you should be very careful with this command because you can accidentally delete your whole home directory if you're not careful. So I'm going to include the I option. So it will ask me before it does anything. I'm going to recursively remove thesis, the entire directory and its contents. It says, do you want me to go down into the directory? And I say yes. Do you want me to remove this file? I say yes. Do you want me to remove the empty directory? Yes. And then it's done. Okay. Let's say if I type ls now, I see thesis is gone, but I do have the backup at least in case that was an accident. If I do -ri, you can combine the -r and the -i and just do -ri. Now let's say I try to delete that, and it's asking me, do you really want to do it? Let's say no, because maybe that was an accident and I didn't actually want to delete my backup directory. So if I type ls, it's still there. Okay. So everybody be careful with the rm command, please. What do you do if you want to copy or move several files at once? So there's an exercise related to this. Let's go ahead and just do it together. So go down to this one. So it says copy with multiple file names. It says for this exercise, you can test the commands in the shell lesson data/data directory. So it has us answer the question in the example below, what does CP do when given several file names and a directory name, right? So it says we can go to the data directory, cd data ls, okay. It has us make a new directory, so make dir backup, and then cp amino acids.txt, animals.txt, and backup. Okay, so what happens? And we can do it without that slash. So if I type ls backup, it made copies of those files and put them in the backup directory. All right, so you can give it multiple file names, and the last argument should be a location or a target directory, so it knows where to put those files. And the next question asks, in the example below, what does CP do when given 3 or more file names? So if we type ls-f, this is what we see. And then we type cp amino acids.txt, animals.txt, and then morse.txt. I'm just going to copy that and paste it and see what happens. So instead of a location or a target directory, we gave it a third file name, and it gives us an error. So it's expecting if it has more than 2 arguments, it's expecting the final one to be a location of where to put the first 2 arguments. And if it's not a location, if it's not a directory name, it gives us an error. Okay. Okay, we're going to talk a little bit about wildcards for the next part. So let's go back to our shell terminal here. I want to go back to, I'm in data and I want to go up 1 level to shell lesson data. Okay, so let's go back there. And type ls. Okay, next we want to go into the molecules directory. Okay, so I go into molecules. I see there's a number of different .pdb or protein data bank files here. Okay. So I want to talk about the wildcard character, and that's the asterisk. So you can access several different files at once by using the wildcard character. So let's say I typed ls star dash or .pdb. That means list everything that ends in .pdb, and the wildcard is, the star is a wildcard, so it can start with anything. As long as it ends in .pdb, it will list it. So that lists everything that's in here. What if I type lsp star.pdb? That'll list everything that starts with a P, and then anything can be after that, as long as it also ends in .pdb. So that only matches these 2 file names, pentane and propane.pdb. So we could try another example, ls star ethane.pdb. That matches both ethane.pdb and methane. So the wildcard can match 0 or more characters. In the case of ethane, it matches 0. In the case of methane, it matches 1 character. We can have multiple wildcards, so we can try lsp star o star dot pdb. And that will limit our match to just propane. It doesn't match pentane anymore because there's no O in it. There's another wildcard, which is the question mark. And this is similar to the asterisk, except it only matches exactly one character. So instead of 0 or more, it has to match one character. So something to, an example that illustrates this well is the ls question mark ethane.pdb. So instead of matching both ethane and methane, it will only match methane. Okay. And if I do ls star dot PDF, for example, instead of PDB, it gives me an error. It says it can't find anything that ends in .pdf. Okay, so the asterisk and the question mark wildcards are really useful tools in specifying which files or a list of files that we're interested in using as our inputs. Okay, so let's go back to our exercises. We're going to spend just 5 minutes, just work through as many as you can. Start with list file names matching a pattern. Just in the interest of time, I want to make sure that we are able to get through our last lesson, which is on pipes and filters. So get through as many of these as you can in the next 5 minutes. We'll come back at 11:40 and we'll start in with the next lesson, okay? Okay, we're going to go ahead and move on to the pipes and filters lesson. I've put the link to the software carpentry lesson that we use for exercises into the chat, but you can just go back and to this main menu and click on pipes and filters if you want. Okay, but we're going to start with the hands-on stuff that we are doing together. So let's go ahead and go back to our terminal. So pipes and filters. We're going to learn a few new commands in this lesson and learn how to take advantage of a programming model called pipes and filters to automate tasks quickly and with as little work and with as little typing as possible. So as I mentioned before, the commands that we type into the shell are actually programs. And every program has an input stream and an output stream. And the input is the input arguments that you give it, and the output is what it prints out to the screen. And then a filter, so when we talk about pipes and filters, a filter is what we call a program that transforms one input stream into a different output stream. So it's just a program. And then a pipe is something that feeds the output stream from one program into the input stream of another program. And you can combine pipes and filters, and filters, like I said, are just programs, in a way that gives you a really powerful and flexible set of tools for manipulating files and data sets relatively quickly. So let's see, I'm going to clear the screen and then CD back up one level. You could also do CD tilde shell lesson data if you want. So we should all be in the main directory there. Okay, the files that we are working with are actually they're in the molecules directory. So we're going to go back in there. So we type ls. We're going to CD into the molecules directory again, and then see what's in there. These are the protein data bank files that we saw before. All right, so these files that we downloaded are actually meant to be simulating the files of a researcher named Nellie. So that's what the software carpentry lessons are based on. We're imagining that we're a researcher named Nellie. Nellie needs to know the number of lines in each of the files that are located there. So a handy command to count the number of words and characters and lines in a file is the word count command. So WC. And then the argument we give it is the name of the file that we want it to count the lines and words and characters in. So let's give it all of the files in here. So WC star.pdb will list that information for all these files. So first it gives number of lines, followed by words, and then characters in the third column. Okay, so it's easy with 6 files, it's easy to see which have the, for example, the least number of lines. So which file is the shortest. But if we had thousands of files in here, or even hundreds, it would be much harder to just see it visually. So we'd want a programmatic way to do that. All right. So word count is a filter, is a program. It filters the input, which is the list of files we gave it, into output. Here's the output stream. If I just want the number of lines, so Nellie just wants the lines, we can do -L, and that will restrict the output to just showing us lines. So this just shows the number of lines in each file. So if we want to know the file with the least number of lines, like I said, that's really easy in this case, but what if we had hundreds of files in here? First, let's redirect the output. Instead of having it print to the screen, I'm going to redirect it to so same command, and then the output, I'm going to do a little greater than sign, and then have it create a file called links.txt and put the output into that file instead of printing it to the screen. Okay, so now when I press enter, it looks like it didn't do anything, but it actually did. It just put the output into links.txt. I can type cat. Cat is short for concatenate. It's a program that just will show me the contents of a file. So cat links.txt, and I see the output is there. Okay. So now that we have a file containing the links, we want to use the sort command. So we want it to sort this file based on the first column in that file. So sort the lines in those files. So sort, and we want it to sort numerically. And this is important because if we didn't do the -N to specify numerically, it would just sort based on the first character that it came to in each file, and so on. So for example, I don't know, we can try it without the N and it'll show you what happens. So let's try it without the N first. Right, so it sorts in ascending order. So it's meant to go from smallest to largest, which it kind of does, right? So these are correct. This is correct. But then the 9, actually, it should be at the beginning, and the 107 should be at the bottom, right? So let's make sure that we sort it numerically. Let's put the -N in there. That way it will come to the end of the first number and sort based on that, rather than just the first digit that it comes to. So, okay, if I sort it using -N, it sorts it the correct way that I wanted. Okay. So let's take that command we just entered. We'll use the up arrow to do it again. And let's redirect that into a new file called sorted lengths.txt. Okay, so we're creating a new file and we're putting the output of the sort command into that file. Now I can look at that. Cat sorted lengths.txt shows me the sorted output. Okay, now what we really want is just the answer to our question, which file has the least number of lines, is just that first line. So to get the first line from a file, we use the head command. Head-N1 means I just want the first line. Head-N2 would mean I want the first 2 lines, but we just want the first line. Okay, all right, so there's our answer. That's the final answer we wanted. The question we wanted to answer is, which of these files has the least number of lines? And we found it. But there was several steps, and we had to create 2 intermediate files, links and sorted lengths.txt, which is not ideal. So is there a way to bypass the creating of those intermediate files and just pass the output from one command to the input of the next command? And of course, the answer is yes, and this is what pipes are. So let's do it for the sort step. So sort-n lengths.txt. And then instead of redirecting that, we're going to use a pipe, which is a vertical bar. That means take the output from this command and don't put it into a sorted lengths.txt file, but rather feed it into the input of the head command. Okay. So there's our answer. We were able to bypass the need for this sorted lengths.txt file. What about that links.txt file? Let's get rid of that. So the first command, if you recall, was the word count. So word count -l star.pdb. Okay, let's not put that into a length.txt file. Let's pipe that into the sort command. And then let's pipe the output from that into the head command. Okay. So there's our answer. And we didn't use lengths.txt or sorted lengths.txt. We just used a few different programs, word count, sort, and head. And then we piped the output from one into the input of another. And we got the answer pretty quickly. So this is the programming model that we're talking about when we say pipes and filters. It's very modular, right? Because there's a lot of different programs you can use for this. It's simple, it's powerful, and it's quite fast. So one final illustration of this method, for one final illustration, we're going to go to a different directory. So I will do clear, so everything's at the top of my terminal. Let's cd up one level. So we should now be in the shell lesson data directory. And then I want to go into the North Pacific Gyre directory from here. So cd North Pacific Gyre, I'm going to use tab completion, so I don't have to type that whole thing out. And then from there, I actually want to go one level down into that data directory 2012-0703. So let's go there. Everybody should be in this directory. Okay, let's do a quick ls. There's a number of .txt files. These are data files. And they need to be, so what we're going to do tomorrow is we're going to analyze these data files with a script. And our researcher, Nellie, needs to make sure that each of the files has the correct number of lines and make sure that there's no missing data or files that have too many lines or something like that. So let's do word count like we did before. And we want to count the lines in all of the .txt files. These are the data files that we're using this time. Okay, so that's what we've got. It is easy to see here that one of them has fewer lines, but if there were hundreds of them and we wanted to know at a quick glance without having to visually inspect every single line here, we would use the same method we used before. So wc-l star.text, pipe that into the sort command, sort-n, make sure it's numerically, and then finally pipe that into the head command. And let's have it show the 5 files with the least number of lines instead of the one file. Okay, so the one file that does have the least is this one, and then the rest of them all have the same number of lines. Okay, so we know that file, for example, maybe is incomplete, and maybe we should exclude it from our analysis when we finally run the analysis on it. So what if we want to check for too much data or some files that are that have errors in them? Let's do the same thing. And instead of the head command, we're going to use the tail command. This will show us the last 5 lines instead of the first 5 lines of the sorted results. Okay. Tail-n5. Oops, I'm sorry. I have a typo. Okay, there we go. All right, so now we're showing the last 5 lines, and the last one is the total, of course. And so when Nellie runs this, she realizes that some of the files end in, instead of just A or B, they end in Z, and that indicates that there's a problem with the file, so she wants to exclude those when she runs her analysis. So in order to just list or use all of the files that end in A or B .txt and exclude the ones that end in Z, there's a way to do that. We could do ls star. Let's say we wanted to first list everything that ends in z.txt, so we could do that. What if we wanted to instead list everything that ends in either an A or a B .txt? In that case, we would put the A and B in these square brackets. And that means anything that ends in A or B .txt. You could make it A, B, or C, for example, if you wanted to, right? and then list all of that. So all of the files it outputs here should end in ARB.txt. We're going to use this tomorrow when we analyze these files. So we're going to tell our script to only analyze files that end in ARB.txt. Okay, so we have a few minutes left for working on the exercises from this lesson. And then we're going to wrap up and continue with the rest of the shell lessons tomorrow. So go ahead and start working on get as far through the exercises as you can for this lesson. And just speak up if you have any questions or if you get stuck anywhere. You'll want to be on the pipes and filters software carpentry lesson, and then just scroll down until you get to the first exercise and start working there. When you finish that one, scroll down to the next exercise. So all the exercises have the little pencil icon. Okay, I will mute myself and we'll work until noon. If you have questions along the way, please ask and just unmute yourself or type the questions into the chat. And then I would please ask that everyone fill out our sticky note survey, which is just a really fast way for you to give us feedback. I'll put that as a link in the chat. Oops, hold on.